Okay, welcome to day 6 of Advent of Code 2024. So, the historians used their fancy device again, this time to whisk you all the way to the North Pole prototype suit manufacturing lab. In the year 1518, it turns out that having direct access to history is very convenient for a group of historians. You still have to be careful of the time paradoxes, and so it will be important to avoid anyone from 1518 while the historians search for the chief. Unfortunately, a single guard is patrolling this part of the lab. Maybe you can work out where the guard will go ahead of time so that the historians can search safely. So you start by making a map of the situation. So you see, this is the example output. So the map shows the current position of the guard with this symbol to indicate the guard is currently facing up from the perspective of the map. Any obstructions, which is has a pound sign. So these obstructions will make the guard turn in a specific direction. So he has a very strict protocol. If there is something directly in front of you, turn right 90 degrees. Otherwise, take a step forward. So that's the basic simulation that we need to do. So you can see here that the guard starts here. He will go up. He will turn into an obstacle. He will face right. He will go this way. He will then face down until he hits that. He will again go there, go there, go there, go then go here, then go here, then go here, then go there, then go there. I think, yeah. So in this example, the guard will visit 4 distinct positions in the map. So then we will predict how many distinct positions the guard will visit before leaving the mapped area. So just for time constraints issue, I can actually already pre-written some of the code. So we read in the well, let me just bring in the test input here. Yeah, so like that. So we start by reading in the test input. So the map will contain a list of string. We can easily index that in list, so that makes the graph. So the first thing we need to do, if we look at the example again, we first need to actually find out where this guard is in our map. So we need to find the position of that guard. So I'm using a tuple for these coordinates. It's the easier way to do it. So let's define our guard position. And I've created a method. Basically, we just loop through the grid until we find that symbol. Then we know it's then we return that. So now we have our guard position. So now we need to simulate this guard movement. So I am going to use I'm going to write a method for this. So we will have something called and this method should return the number of unique visited locations. that this guard has done. So we have a simulate guard movement, call it simulate guard movement. It takes in the list of string, which is our map. It also takes in our row and col of our guard position. So we need to have a hash set of visited nodes. So and this will of course contain our intro call. So now we have our visited set. I'm also well, when I first did it, I actually used an enum for the directions, but I found out that this was a bit tedious to make it work like that. So it's better to just indicate the directions via the vector here. So let's define our current direction, which will be which will be of the same. We will call that direction row and direction column. So in DRDC, it's better to have it like that. So we call it current dir maybe, and that will, and the starting direction is always up, as we saw in the description. So we go, so up is indicated by -1 0, and I have also a method to cycle the directions later on, and yeah, we can look at that. But this is our starting direction. Then we have a while loop. No, sometimes you just get real tired of that IntelliCode thing. While true, we add our guard position to, now we have visited that position, as it is our first position in this case. So what do we need to check? Well, we need to have some conditions we need to set. So in the end condition is if we actually are going, if we are about to leave the map, or if we are actually off the map, so that the current guard position is off the map. So that's where I actually have a method for that. So what we're going to check if this next position row is greater or equal to the map's row count, and if the column is greater or equal to the length of the row, or if the row is less than 0, calls is less than 0. So that is basically the off the map method. So if it's off the map, will be our map, and then we actually have to say guard position row plus our current dir.dr guard position.col plus current direction.dc. Yeah. So that's the is off the map. Have I forgotten something? Yeah, maybe I have to have a yeah, no. Yeah, that's it. Then it's that. It's that. Okay, yeah. Yeah, it was just waiting for me to do something. Yeah, so when we are off the map, we're going to break out of this, and in the end, we are actually going to return the visited got count. So now we need to check. Now we need to do two things. So if the map with the guard position row plus our current direction row and our guard position column plus our direction column, if that is yeah, it's a char. If that is a pound sign. So if that is a pound sign, we will actually change direction. So we will call our cycle direction method. That will be we send in our current direction. So let's just look at that method briefly. So this is just a basic. I know that we could have probably done this with some math operation, but I didn't actually felt up to it, or when I did this, I was tired. So that I was actually at the Christmas party last night, so I'm a bit tired. Yeah. So basically, when we are going up, the next direction should be going right, and and if we were going right, the next direction will be going down. So if we are going down, we're going left. If we are going left, we're going up again. So that's the cycle of directions. So we change direction, and if we're just moving, we will just update our guard positions, row and column. Yeah. So after that, we can say we can have our part 1, or after that we have our part 1 answer. And we should have 41 distinct positions as our answer. So let's just check it. Yeah, so we get 41 here. Let's go back to the problem here. So for part 2, While the historians begin working around the guard's patrol route, you borrow their fancy device and step outside the lab. From the safety of a supply closet, you time travel to the last few months and record the nightly status of the lab's guard posts on the walls of the closet. Returning after some time, like only a few seconds, to the historians, they explain that guard patrol area is simply too large for them to safely search the lab without getting caught. Fortunately, they are pretty sure that adding a single new obstruction won't cause time paradox. They like to place a new obstruction in such a way that the guard will get stuck in a loop, making the rest of the lab safe to search. To have the lowest chance of creating a time paradox, the historians would like to know all the possible positions for such an obstruction. The new obstruction can be placed at the guard's starting position. The guard is there right now and would notice. In the above example, there are only 6 different positions where the new obstruction would cause the guard to get stuck in a loop. The diagrams of these 6 situations use an O to mark the new obstruction, a pipe to show a position where the guard moves up and down, minus to show the position where the guard moves left and right, and a plus to show a position where the guard moves both up and down, left and right. So the basically what this problem is that we need to simulate the guard movement, and we need to actually put obstacles in the way of the guard and check if that guard is looping. And obviously the real data is pretty large, but as I implemented this, I thought maybe this would take too long to just do a brute force solution for this, but I don't think it will be that bad actually. So how do we do that? Well, we will do a variation of this method. So we can actually copy this method. So we will do it. We're gonna do a new method for this. So we're gonna this method will return bool. We want to call it is guard looping, and it will take the same parameters in. Our visited set will now be expanded because basically what we are going to check here is not how many places that the guard visited. We need to actually keep track of not only the positions, we also need to track the direction vector as well. So the visited set should include direction row and direction column as well. And yeah, so we will also have so we need to actually expand this a bit. So we need to say the guard post row, guard post call, current direction .dr, current direction .dc. Like that. So now we add our visited. We fill up our visited hash set. So we will check if we. So if we're going up the map, then that's the first condition that we are going to change. So in this sense, we will actually return false, because if it's going off the map, it's not if the guard is going off the map, he's not looping. So that is the thing. And the other condition that we are going to check is that we'll remove that. So the only other thing that we need to change actually is that we need to check if the visited hash does contain. So if the guard comes back to the same position, then we know he is in a loop. So we guard row call so if it is in a if the guard comes back, then we are in a loop, like that. So that is basically what we need to do now. The other thing we need to do is actually loop through. So the brute force way to do this is actually to test all the locations, to put an obstacle in all locations and test if the guard loops. So that's what I initially thought might be a little bit time consuming, but my solution with my real input data took about 2.5 seconds to run. So I think that's acceptable. I mean, we're not writing enterprise software here, so I have not optimized it anymore. But obviously you could do several optimizations to this, but I cannot think of anything right now. So let's just go ahead. So we will have a for row. Oh. For row. Yes, that's correct. So row and call. Yeah. And if the current, so if the current location is not an empty space, so if the row and call is not an empty space, we will actually just continue. Otherwise, we will actually we will put an obstacle in that position. So we do map row equals map. So we need to do it in a two-step solution, as we are now working on a string within a string list of strings. So it's a little bit tedious to work with in this case, but actually, but it can be done. So we begin by removing that empty space. We take and we insert an obstacle at that position, and the string we're going to insert is a £. So and now we can use our method. So is God looping? We send in the map and the God position. And if so, well, we also have some kind of counter to update. So we have had a count. So then we update the count. Yeah. So let's just add our output here as well. So we say part2 video count. But of course we also need to do one more thing that we actually need. So when we put in this obstacle, we must replace the obstacle with an empty space before we try the next loop, the next iteration, because otherwise we will clog up this map with obstacles, so it will not work. So we remove the obstacle and insert the empty space again. So let's run it. Check. We should see like 6. I think it was. Let's say that. Let's just check. There are 6 different positions. So we have 6 in our answer here. Yeah. So this was a pretty fun little puzzle to solve, actually. So I usually like these grid problems, and it's fun to do simulations. And this was a pretty simple one, but also a little bit tedious. And it took a while to actually get part 2 working for me, because initially I just what I did wrong actually from the beginning was that I just kept adding the God positions row and column in that visitor set, and then I never got the right answer. So it was actually until I realized that I also have to have the direction vector in that to make it more unique. That way we will detect when it's a loop. So that pretty small change actually, because I tried it many times, debugged it, and yeah. So I couldn't get it to work, but with these added, it worked. So it took me about 1 hour in total today. So that's a little bit, but also I stayed up late last night. It was a Christmas party at my workplace, so yeah, I was a little bit tired this morning. So that could happen. So I mean, this advent of code is not actually a sprint; it's a marathon. So to be able to take this all the way to the end, it'll obviously be a challenge. So I hope you tune in tomorrow for my next attempt. So for today, this is me signing out. Bye bye.